Okay, so right now, what we're going to do is we're going to see how we draw a piecewise function for absolute value functions. Okay, so here's what I need you to understand. Let's say that I ask you to draw this function. Y is equal to negative 3x plus 2. But this time, what we're going to do is we're going to use the absolute value of that function. The key to success for drawing these types of functions is you need to understand something about the graph. So normally, you would draw this graph as, if I had the graph y equals 3x plus 2, normally you would draw something that looks like this. And basically, we have our graph of negative 3x plus 2. And what's crazy, remember that's negative 3x plus 2. What's crazy is the absolute value literally just reflects everything below the line the x-axis above it. So imagine the second half of my graph looks like this. So now there's my graph, and I have to erase this whole portion of my graph. So that is how we would draw a absolute value of a graph. So imagine I give you another one that looks like this. So imagine I give you the graph y is equal to negative x plus 1 squared plus 4. But this time I want you to do the absolute value of that. So normally when you graph a problem like this, right, what's going to happen is you either use your vertex and your step method, or you find some way to get the vertex and the two x-intercepts and you graph it, right? So you're going to end up with a graph for something like this. So you start with y is equal to negative of x minus 1 squared plus 4. So you start with this and we graph it. So what you're going to have is something that looks like this. So at 1, 4, there's our vertex. And when we do this, we have negative 1 and 3. And our graph would have looked like this. So you would have spent the time to graph your regular graphs, right? But like I told you before, we're actually doing the absolute value. So what we have to do is we're going to have to look at these things here that's underneath the x-axis, and we're going to reflect them up. And when we reflect them up, our graph looks like this. And all we have to do now is erase everything that's underneath the line. And by erasing it, we end up with something that looks like this. So that is how you go and graph the absolute value. So once you're done, the last part is, in our problem, we always flip the negative parts of the graph to positive. That's it. And we've literally created a piecewise function for this, right? So if I ever asked you to graph it, you could easily do it. So one more time, with the graph, you take the inside part of the graph and you graph it. Then you flip the negative parts up above the x-axis and then erase the bottom half. All right, so this next problem says to express f of x is equal to x minus 3 over absolute value of x minus 3 as a piecewise function. So here's the first thing that you need to remember. For an absolute value, there are two halves. There's a positive half and a negative half. And for this one, the only discontinuity happens at x is equal to positive 3. So at positive 3, we don't know what that is. We can't calculate it. So there is a positive half that looks like this. X minus 3 over x minus 3. But it's going to be for x greater than 3. Okay, so for these type of problems, the discontinuity is where our boundary is. Okay, so for the positive half, it's x greater than 3, and then for the negative half, it's x minus 3 over the negative of x minus 3. And that's for x being less than 3. Now, because we've ensured that x minus 3 cannot equal 0 on the bottom of our fraction, we can easily say the following. We can cancel the top and cancel the bottom of the first part. So now the top half of my equation is just 1 for x being greater than 3. And for the bottom half of my equation, I can cancel x minus 3 and x minus 3, and that gives me negative 1 for x being less than 3. So that is our basic equation for this absolute value type problem. You'll see problems like this in today's work. So here's a problem that I want you to be able to do, right? I want you to be able to find the value of k such that the function is continuous for this piecewise function that we have here. Now, the other things I'm going to tell you is that k is less than 2 for the first half, and k is greater than or equal to 2 for the second half. All right? Now, remember when we were looking at continuity, if I had something that was continuous, I could draw a line continuously and never take my pen off the paper. In order for us to do that here, mathematically, we have to let the following happen at the discontinuity. The discontinuity here is at x. We have a possible discontinuity at x equals 2. Because we have our boundary at x is 2. And to make it continuous, we have to do this. We have to make k x plus 2 equal to the right side of our equation, x squared plus 1. First of all, right? Then we actually have to put in, then we actually sub in where we could have our discontinuity. So when we sub in x is equal to 2, we have 2k plus 2 is equal to, well, 2 squared plus 1. So this right side ends up being 5. The left side ends up being 2k plus 2. And when we finish, we end up with 2k is equal to 5 minus 2 is 3. And then we divide both sides by 2. And we end up with k is equal to 3 over 2. Now, to finish this problem, you just say, to make the function continuous, k must equal 3 over 2. All right, and that's it for the day. Your job is to do these following questions. Your homework is page 89, and you're going to do number 17, 19, 21, 27, 29, 31, 33, 41, and 43.